What is binary? Today, we will find out. Humans have engineered ways of representing physical and theoretical quantities for tens of thousands of years. Notched bones and sticks dating as far back as 44,000 BCE evidence the primal urge to count or tally, an instinct that persists to this day. Although we no longer use bone to record quantitative information, our modern numerical system can take on many different forms. Let me ask you this. Do computers understand numbers the same way we do? Well, no, not exactly. Computers understand a system called binary.
So what is binary? In our daily life, humans use a decimal system to represent numbers, which means that you have 10 digits from 0 to 9 to represent any quantity you need. In the binary system, computers only have 0 and 1 to communicate all information. Here on the left is the number in the decimal system, while on the right is the same quantity being displayed in binary. Think of a binary number as a sequence of boxes putting next to each other. Each box has a number and a value. The value depends on the position of that box in our binary number, with the value of the next box is twice the value of the previous box. The number part of our boxes will form our binary number. The number either 0 or 1 will tell whether or not we are going to use that box value for conversion, with 1 means yes and 0 means no. Then to convert a binary number to a decimal number, we simply take the sum of all the boxes whose numbers are 1. As you can see here, 214 in decimal system is equivalent to 1101. 0110 in binary. As the binary can grow indefinitely deep into the left, we can represent millions, billions using binary. There is no limit on how big a number can be. Just like a decimal system, if you need a bigger number, you can simply add one more digit to your number. Since computer only speaks binary, humans ask a translator to help computers understand characters, called ASCII table.
Every key on a keyboard can be turned into a corresponding binary number. We are able to do this because of a standard we have called the American Standard Code for Information Interchange, or ASCII. This table shows which character corresponds to what binary number. ASCII uses 7 bits, which means that the maximum number of characters is 127. Unfortunately, this meant that there weren't enough characters to account for other letters or symbols that other languages use, such as Greek, Cyrillic, Latin, and much more. Having different encoding in different countries meant that the code was not compatible with each other, which wasn't a problem for the most part until the internet. Thus, Unicode was created. It incorporated ASCII, so the first 127 characters are exactly the same, but it uses more bits so more characters can be used. It uses 32 bits, which means there are 2,147,483,647 possible characters that can be used. The majority of websites, search engines, and operating systems use Unicode today.
Now that you understand binary, let's test your understanding and decode a secret message. If you get this, you're on your way to becoming a computer pro. Feel free to pause the video for as long as you need, and I'll give you a hint. To crack the code, use the ASCII table we mentioned earlier in the video as your guide. Okay, time's up. Now I'll walk you through the process. Let's take the first part of the code. On the ASCII table to the left, we see that 89 corresponds to the letter Y. Next, in the secret message, we have number 79, which, if you look at the ASCII table, corresponds to an O. As you can see, 85 corresponds to the letter U. Now we've finished our first word. In our second word, we have 71, which is a G. Now we have the number 79, which we have previously seen, and that is an O. Now for the last symbol in the second word, we have an 84, which corresponds to a T in the alphabet. Okay, now we're on our last word. As we see in the table, 73 is the letter I. we have previously seen 84, and that is a T. And finally, we're on our last symbol, which is a 33. That corresponds to an exclamation point. Good job and congratulations! Now you know how computers understand numbers and letters. Thanks for watching!